So let's look at that one more time. Josh can stock the shelves in 4 hours. So that means Josh's rate is 1/4. We did not know Tyler's rate. That means Tyler's rate is 1/x. Now the other piece of information that we have not used yet is that it takes the two of them 3 hours working together. So working together, they're both working 3 hours. That goes in time worked. So 3 here, 3 here. And then to fill in the remaining column, we're going to follow our formula again. Rate times the time worked equals the portion of work completed. So we're going to take 1/4 times 3/1 is 3/4. Remember, you don't need a common denominator when you multiply. And then 1/x times 3/1 would be 3/x. And that will give us our equation. So we want, Josh has done 3/4 of the shelves. Tyler does the remaining portion, and we want them to have stocked the entire set of shelves. So that translates to Josh's portion plus Tyler's portion equals 1, because we want them to have completed one entire task. And you will notice that all of our work problems are going to be set up this way. The two are going to be added together, and it's going to be equal to 1, so they will have completed one task. Now, to solve an equation such as this, just like last time, we need to multiply by the common denominator to eliminate the fractions. So the common denominator is 4x. So we're going to multiply each term by 4x. Okay, then I distribute the 4x through to everything. Then we cancel out. The 4's cancel out here. The x's cancel out here. And then, of course, there's no fraction here, so nothing cancels out over here. So that's going to leave 3 times x and 3 times 4. So that produces 3x plus 12 equals, and then the 4x times 1 is 4x. Again, we have a linear equation since x is raised to the first power only. X is not being squared. So it's a matter of getting the x on one side by itself, isolating the x. So we subtract 3x from both sides, which gives us x equals 12. Now, when we look back at our setup for the problem, we had this. Tyler's rate was 1/x. It was 1/x because we did not know how long it would take Tyler by himself. If we had known it would take Tyler, let's say 5 hours, then Tyler's rate would have been 1/5. So that means that if x is equal to 12, it takes Tyler 12 hours by himself. Now if we think about that again logically, together it takes them 3 hours. Josh takes 4 hours by himself. Tyler takes 12 hours. So it's 3 hours for the two of them together, which is less than the other two, which seems about right because the 3 hours is not that much less than it takes Josh by himself. So that means Tyler is not helping that much, and that's because he's a good bit slower than Josh. Okay, let's take a look at another example. A tank has 2 drains. One drain takes 16 minutes longer to empty the tank than does a second drain. With both drains open, the tank is emptied in 6 minutes. How long would it take each drain working alone to empty the tank? Okay, so let's analyze the times that the problem has given us. One drain takes 16 minutes longer than the other one. So we don't know how long that one takes, we just know that it takes 16 minutes longer than the other. Now with both drains open, the tank is emptying at 6 minutes. So that 6 minutes is not a rate for either one because that's both drains working together. So what this means is we don't know the rate for either one. Alright, let's take a look at our setup. Okay, let's call them drain 1 and drain 2 for lack of a better name. And then across the top we have rate times time worked equals the portion of work that is completed. Now we said we didn't know the rate for either drain. Okay, so we don't know one of them, we're going to put 1 over x. But we do know a little something about the other. Let me show you that again. We know that it takes one of them 16 minutes longer than the other one. So that means that if one drain is 1 over x, the other would be 1 over x plus 16 because it's 16 minutes longer than the other. Now, for the time worked, we do know that when the two of them work together, it takes them 6 minutes. So together they're working 6 minutes, so 6 minutes for this one and for that one. Okay, so let's repeat. We don't know the rate of either one. And remember, the rate comes from the length of time that it takes each one working alone. So one of them is 1 over x, and we did know that one of them took 16 minutes longer than the other. So that's x plus 16. And the time worked was 6 for both when they were working together. So we're going to do the same thing we've been doing. 6 over 1, 6 over 1, and then multiply across. So that'll be 6 over x, and this one will be 6 over x plus 16. Now what we want is for both drains to work together to empty the tank. So we're going to add the two portions together and set that equal to 1. Now again, the common denominator for this problem is a little more complicated than the others. This common denominator would be x times x plus 16. So we would put x and then x plus 16 in parentheses. So we've got to multiply everything by x times x plus 16. Now this didn't quite fit across here, so I'm going to go through it and show you from side to side. So x times x plus 16 times the 6 over x plus x times x plus 16 times 6 over x plus 16, and then x times x plus 16 times 1 on the right hand side. So let's go back and look at the left hand side. So we have to cancel out. So in this particular part, this first term is going to have the x's cancel out, and that'll just leave us with x plus 16 and 6. The second part will have the x plus 16's canceling out, and that will just leave x and 6. And then finally on the right hand side, there is no denominator, nothing cancels out. So let's see what remains after we do that. So we have 6 times x plus 16, we have 6 times x, and on the right hand side we have everything because nothing canceled. Then we distribute. So distribute the 6 and distribute the x. Now what happens on the right hand side here is that once we distribute the x through here, x times x is x squared, x times 16 is 16x. When we come back and multiply by 1, nothing happens because when we multiply by 1 we get the same thing back again. So that's why you don't see a whole lot of, you don't see an extra step over here. We just multiply those two together and then times 1, nothing changed. Now, if this had been a 3, then we would multiply those two together and then distribute the 3. All right, now let's see where we go from there.